right, we're looking at our target 4.4 mastery learning objective. I can find the probability of independent and dependent events by multiplying simple probabilities. Okay? So, the formula for the probability of independent events is, right, the probability of A and B equals the probability of A times the probability of B. And this word "and" is what we call our key word. Okay, so you see that word and tells you that you're multiplying. Okay? So looking at our first one, right, we want to determine whether the following events are independent or dependent, and then find the probability. Okay? So you flip a coin and then roll a fair six-sided die. The coin is going to land heads up, and the die shows 1. So if I flip a coin, it doesn't matter what I get on my coin, it's not going to change the fact that, or it's not going to affect what I'm going to roll on that die, right? I still am going to have all 6 choices, whether I get heads or tails. So this isn't independent. So the probability of heads and the die should be and 1. Well, I'm going to multiply them. So the probability of heads, right? Well, there's 1 out of 2, right? There's 1 heads on a coin out of 2 possible choices. And then we multiply die shows 1. Well, on a die, right, there's 1 out of 6 choices. When I multiply these together, we can always use a fraction, but remember, we multiply straight across. 1 times 1 is 1, 2 times 6 is 12. Alright, looking at our second one, you roll a fair six-sided die twice. The first roll shows a 5, and the second roll shows a 6. Right, same thing. When I roll my die the first time, right, I have 6 choices. And when I roll it the second time, I still have 6 choices. My number of choices didn't change. So that's independent, right? So then the probability of rolling a 5 and then rolling a 6, right? First was 5. Well, on a die, there is 1 5 out of 6 options. And on a die, right, there's 1 6 out of the 6 options. Again, with dice, the biggest mistake I get anytime there's a question with dice on a quiz or a test is people want to put, oh, in getting a 5, it's 5 out of 6. Okay? And even when I explain it, they're like, yeah, that's silly, and then we still do it on quizzes and tests. So just be very careful with dice. Oh, sorry. So then when I multiply these together, 1 6 times 1 6, all right, looking at number 3, a bag has 6 black checkers and 4 red checkers. You take out a black checker, replace it, and take out another black checker. So again, I have 10 checkers in my bag. When I look, oh, it's black, and then I put it back, I still have 10 checkers in the bag. The number of options didn't change. So that's independent. So the probability of black and black well, if I pull out a black checker to start, right? There's 6 black checkers out of 6 plus 4 is 10. Times, and then I want another black checker. Well, there's 6 black checkers out of 10. So 6 times 6 is 36 out of 100. We do want to reduce that. Forgot the 100. And that is 9 out of 25. Ran out of room a little bit at the end. Okay. Or, especially as our numbers get bigger, you could do 6 out of 10 times 6 out of 10. Calculator gives it right to you. Or if you really want to do it in your head, right, separate work out of here, sometimes it's easier to reduce first. I know 6 out of 10 is 3 out of 5 times 3 out of 5, which is 9 out of 25. Okay, so whichever method of math you like, that's fine by me. I don't care. I just like showing you these things because remember next year when you take the SAT, there are non-calculator portions. So some of these tricks like reduce first and then multiply is helpful for the non-calculator part of the SAT. All right, looking at our next one. Drawing a 1, 2, or 3 from 9 cards numbered 1 through 9. Replacing the card and drawing a 7, 8, or 9. So, 2 or 3, and 7, 8, or 9. And this is another one where I'm replacing the card. So my number hasn't changed, right? So this is independent. So the probability of drawing a 1, 2, or 3, well that's 3 cards out of the 9 cards. And then drawing a 7, 8, or 9, well that's 3 cards out of the 9 cards. And just like I did last time, let's simplify it first, right? Which is the same as 1/3 times 1/3. Which is 1/9. Alright, go ahead and turn the page. So number 5, a box contains a penny, a nickel, and a dime. Find the probability of choosing a dime first, and then without replacing it, choosing a dime. Okay, so we're drawing a dime both times, but if you look here, without replacing it, right? So I have a penny, a nickel, and a dime. I have 3 coins in my pocket. I pull out my dime. I now only have, and I don't put it back, I now only have 2 coins in my pocket. The number has changed. This is dependent. So, probability of dime and dime. Well, the probability of choosing a dime the first time, well, there's 1 dime out of 3 coins. Now, I've chosen a dime. There's only 1. The dime's gone. So now if I choose a dime again, well, there's 0 dimes and only 2 coins. So the probability of choosing 2 dimes out of your pocket is 0. 1/3 times 0 divided by 2. Anytime there's a 0 in that calculation, the answer will be 0. So there is no probability of choosing 2 dimes. All right, looking at number 6. The teacher of a class that contains 12 boys and 16 girls needs to pick 2 volunteers. Find the probability it chooses a girl first and then a boy. So if I'm just randomly picking people, right? Well, I need 2 volunteers, right? If I choose a girl, I can't put her back because if I accidentally choose her again, then I only still have 1 volunteer. So a lot of times questions like these, it's not obvious that you're not replacing. We saw one yesterday, I think, where we ate the jelly bean, right? It doesn't say without replacement, but we're not going to spit a jelly bean back into a bag, right? So a lot of times you have to think about, am I putting this back or am I not putting it back, okay? So when I choose that first girl, she's out of the group that's remaining. So this is dependent. My number of volunteers changes. So the probability of girl and boy equals so the probability of girl, well, there is 16 girls, and then 12 plus 16 is 28 total, right? Now, I've chosen this girl. So when I go to choose a boy, well, there's still 12 boys remaining, but now 12 plus 15, there's 27 total. So it's kind of like where our fundamental counting principle, right, from yesterday, the number decreases, but our total, right, is being multiplied. I can still do this, right? This I can divide by 4, that's 4 out of 7. 12 and 27 are both divisible by 3, that's 4 out of 9. So that equals 16 out of 63 is my probability. And again, tests, quizzes, feel free to use a calculator. Good to practice our mental math, though. All right, last one, numbers, or not last one, just kidding, 2 more. So a box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. What is the probability of taking 2 purple marbles? Okay, something like this is the same as saying a purple and a purple without replacement. Okay, so anytime it says like I'm gonna do 2 of the same thing, right? A purple and a purple without replacement. Okay. So again, since I'm not putting it back, my total number is going to change. So that's going to be dependent. So the probability of purple and purple. Wow, my first purple, there's 5 purple. And my total is 5 plus 3 is 8, plus 2 is 10. So now, I've picked out one of my purple marbles. I didn't put it back. There's now 4 purple marbles in. So when I go to choose my second purple, there's now 4 purple marbles, and 4 plus 3 plus 2 is 9. Well, this equals 1/2. Another trick for reducing and multiplying fractions is you can, anything in the denominator can cancel out with anything in the numerator. So I can cross out this 2 right? And this 4, and replace it with 2 and 1. Because both of those have a common factor of 2. So I just took out the common factor. Okay? This one wouldn't have been too difficult, but you would have had to reduce at the end anyway. So sometimes you can reduce through your problem. And then 1 times 2 is 2, and 1 times 9 is 9. So we get 2/9. Same thing with number 8, right? You wear 8 shirts in your closet, 4 blue and 4 green. You randomly select one to wear on Monday and then a different one on Tuesday. You wear blue both days, right? This blue both days is the same thing of probability of blue and blue. And we are going to assume in this case that when I wear the shirt, I then have to throw it in the laundry. I'm not going to wear the same shirt again. So my number of shirts is going to decrease because once I wear a shirt, right, it has to get washed before I can wear it again. Hopefully. So my first blue, well, I have 4 blue and 4 green, so that's 4 out of 8. My second blue, I now have 3 blue because I wore one of them. So there's 3, and 3 plus 4 is 7. That's the same as 1/2 times 3/7, which is the same as 3/14. All right, and that is it. I will see you guys tomorrow.